In this workshop, you will be thinking about angular acceleration and torque on a bar, and then the effect of torque on a spool that is falling. The equation for torque is shown here. You can see that when the force F is applied to a point a distance r away from the axis, the turning effect tau of that force depends on the size of the force, the distance to the axis, and the angle theta. It will be a maximum when theta is 90 degrees. That is, the force is perpendicular to r. If the force was pulling in the same direction as r, there'd still be a force, but there'd be no turning effect. In part 1 of the workshop, you will be looking at a rigid bar that spins around an axis through its middle. The direction of its angular acceleration will be equal to the direction of the change in angular velocity, and it also has to be the same as the direction of the applied torque. This is just the same as for linear force and acceleration. What is always true is that if an acceleration is in the same direction as velocity, the object will be speeding up, and if the acceleration is in the opposite direction to velocity, it will be slowing down. To find the size of the net torque in Part B, you need to consider where each force is acting. In this case shown here, if I apply a downwards force to each end, the direction of the forces is the same, but the torques will be in the opposite direction because each force will be trying to make the bar rotate in the opposite way. The net torque would be F1 times L1 minus F2 times L2. For Part 2, you have two spools that are cylindrical in shape. One falls straight downward, but the other has thread wrapped around it that will unwind as the spool falls. You can see a similar case here with the forces shown, and that should give you a start to solving this problem. The rest is up to you.